Hi everyone, this is John Wen. Today is February 24th, 2021. Hope you enjoyed a great week in the past week. And in today's video, I still will be able to go through the research updates since my past week. I'm still working on the deep learning workflow, and I think in the past week we made a lot of progress. And here we are working on the NN workflow, which stands for the Neural Network Workflow in DataView 2.2. And now the implementation was aimed to have end-to-end CUDA neural network in DataView. So right now, on Java side, we are able to construct a neural network with each layer as a task. So the whole workflow will be fed into the Endnote Trainer.java, which will output a single specification JSON to feed into the CUDA side. And you can see here the files we have added to construct a new network in the workflow level. If we take a look at the Eclipse, you will notice here is one example workflow that can be constructed for new network. So here you can see we adding tasks as layers. So for example, we can add linear layer which has 5 input neurons, 3 output neurons. We can also add a ReLU layer and sigmoid layer. And we also have to add edges between them to specify the topology relationship among them. So here is one example. If we take a look at the Endnote Trainer, which is quite similar to test.java before, we will specify a workflow will be created. That is an NN workflow 1, which is a file we just saw. And then we can draw the graph for it, as well as we will specify the input port and output port for this workflow. And then we are going to go through the specification on the workflow level, as well as in the task level. And we will construct a JSON file. And that JSON file will include all the specification, or the architecture will be constructed in neural network. And then we're going to feed that into the CUDA side. So here you can see we're going to call the GNI, which is a DLL file. And we are going to feed our JSON data into the method we have in the DLL file. So let's get back to the slide. So this is currently what we have on Java side. And right now on the CUDA side, we also have many progress since the past week. So now we are able to take any dimension of source data. That means no matter how many columns and how many rows you input, we are able to accept, as long as it's a binary classification problem. And the input data will be automatically split into 6 batches. And 5 batches will be used for training and 1 will be used for testing. And the CUDA side will take a single JSON string as input to carry out the whole training and testing purpose. So if we take a look at the Cuda Code, so here is our input data set, which I worked on in the past week, which will take a file name and number of batches. Right now we fix the number of batches to 6. Maybe we can make that flexible one day, but the most important thing is a file name. As long as we get a file name, we're able to read from this file and get a number of columns and number of rows, and then we're going to split them into batches, and we're saving them into batches, and all the data will be saved properly. And then we're going to process the data. Basically just save them and copy the data to device. That means copy the data to GPU. So this is a data preparation file, which is called the input data set. And I also worked on another main file. This is a main load input data. So right now I'm using a data set which is from Kaggle, and here is a data set I'm using, the breast cancer prediction data set. So which has let me show you the data directly. I think that will be straightforward. So here is a raw data. So you can see this is a very simplified data set, and it's a prediction. The diagnosis will be 0 or 1. That means breast cancer or not. And we have 5 attributes, and they have been pre-processed into digit. So I think that's pretty good. And also, I normalized every column of them. So from 0 to 1. So this will be easy to feed into a neural network as well. So this is the data after processed. And the data set include, I believe, 600 or 500 rows. So it's not a big data set, but at least we can have something to work with. So I think the total will be 569. Okay, so let's get back to the Visual Studio. So here you can see in the main file, which will take a single JSON as input, and here is a string, which is what will be output from the Java side exactly. So we have the 3 parts. The first part is about the input ports or input file name, which is a file name for the input data, and also we have an output file name, and then we have layer architectures. So here we can specify, maybe we have 4 layers here, and first layer is 0. That means we are going to have a linear layer, and linear layer will have 5 input neuron, 15 output neuron, and 1 means ReLU layer, and then we can have etc. like that. So you can see right now we only take this only JSON input, and everything will be carried out automatically. So if we run this, and you will see that it has been automatically calculated, and also data has been split into 6 batches, and the training has been carried on. And you can see we have 5 input neuron for the first layer and 15 output neuron for first layer. So similarly, we can specify any architecture we need, and also we can feed any data set we need to carry out the training and testing. So I think that's pretty good, and maybe we do not need to wait until it's running over. And get back to the slides. So this is a thing what we have right now. So you can see both the Java and Cuda side has been ready to either to feed a single JSON or receive a single JSON. But right now, I still have some problem to fill the gap between these two, because we need to compile all the Cuda code into a single DLL, and then we call that from the Java. But right now, if we take a look at the Java side, when I call, actually I have generated a DLL, but right now we still encounter some errors. So again, this will be very troublesome to debug in the system, because there are 2 separate systems, either the Java side and the Cuda side. So from Java side, we cannot get too much insight what is a problem. So right now, if we run this from the Endnote Trainer, we're able to take the workflow and then workflow 1 like this. You can see we have a linear layer, ReLU layer, and linear layer and sigma layer, and then we're able to get a single JSON string, which will be intended to feed into the Cuda side, and this is exactly what will be received from the Cuda side. But right now, I still encounter some DLL issue. I'm not quite sure right now, but I think I will spend some time to figure this out. And on the Cuda side, we will receive this string, and then we will parse that into the JSON. So I'm currently using a library which called a JSON CPP, which is very famous to work in the C++ with a JSON format. And I experienced a lot of trouble, especially with Cuda, because Cuda C++ is a lot different from C++ purely. So I tried many ways to work with the library, and currently I finally figured out a way. So right now it's working fine, and I'm able to easily parse any complexity of data of JSON format. So hopefully in the future we can easily to extend this into any format or any structure of JSON file we have, so we are able to parse that easily and quickly. So I think that's pretty much for today's video, and I hope you enjoy. Until next time, happy coding.